Hello everyone, welcome back to Math with Allison. Today we're going to be working on our derivative series and we're going to be talking about hyperbolic functions. So let's go ahead and dive into it. So here we have with normal trigonometry, we have the unit circle x squared plus y squared equals 1. And a lot of our trig is derived from the triangles, right? We get tangent, sine, cosine, we use SOHCAHTOA, opposite over hypotenuse, all of those things. We also have the identity cosine squared of theta plus sine squared of theta is equal to 1. So that's something that we're used to, right? Hyperbolic functions are a little different. So in this case, instead of x squared plus y squared equals 1, we're actually using the parabola x squared minus y squared is equal to 1. And this is where our identities come in. So here we have the definition. We have hyperbolic sine of x is equal to e of x minus e to the negative x divided by 2. And hyperbolic cosine of x is equal to e to x plus e to the negative x divided by 2. So notice here that this is also going to change our identity. So in this case, we get hyperbolic cosine h squared of theta minus hyperbolic sine squared of theta is equal to 1. And so that's how it changes the identity a little bit. So let's go ahead and go through the rest of these. Since we have sine and cosine hyperbolic defined, we can go ahead and define the rest of these. So hyperbolic tangent is equal to hyperbolic sine, just like normal sine of x, divided by hyperbolic cosine or cosh. And in this case, what we're going to do is we're going to take the e to the x minus e to the negative x divided by 2, and we're going to divide that whole thing by the identity for hyperbolic cosine. So in this case, if you want to rewrite it, we can go ahead and take the numerator, e to the x minus e to the negative x divided by 2, and what we're doing is we're dividing by whatever's in the denominator. But remember, when you divide by a fraction, all you need to do is multiply by them flipped. So multiply by e to the x plus e to the negative x, and here we can see what's really going on. So here we get these 2's cancel out, and we are left with e to the x minus e to the negative x divided by e to the x plus e to the negative x. And there we have the definition for hyperbolic tangent. So now we're going to go ahead and use the rest of these. So we're going to do hyperbolic cosecant, in which we get 1 over, I've heard people say sinh. I feel like that's wrong, but you do what you do. So in this case, what we're doing is we have 1 over, and then the fraction of sinh, e to the x minus e to the negative x divided by 2. But when we divide by a fraction, again, we multiply by it flips, so we can just go ahead and flip that. 2 divided by e to the x minus e to the negative x. So now for hyperbolic secant, I'm going to do the same thing but with cosine, and I'm going to go ahead and skip some steps, so I'm just going to go ahead and flip it. So 2 divided by e to the x plus e to the negative x. For hyperbolic cotangent, that is going to be hyperbolic cosine of x divided by hyperbolic sine of x. And if we follow that same way that we did for hyperbolic tangent, we would end up with the cosh, so e to the x plus e to the negative x. Those 2's are going to cancel out again, and we just divide by the sinh without that 2, so e to the x minus e to the negative x. Or you can think about it as hyperbolic tangent flipped, so, whichever way you like to think about it. But yeah, so those are all of the definitions that we have here. So let's go ahead and actually go through the derivatives of all of these. So when we take the derivative of hyperbolic sine, I'm going to replace it with its definition. So I'm going to replace that with e to the x minus e to the negative x divided by 2. So let's go ahead and take that derivative. I know the derivative of e to the x is just e to the x. The derivative of e to the negative x is going to be negative e to the negative x. So that negative cancels out. That becomes a plus. And we get that. And then that 2 is a scalar multiple. It's a scalar multiple of 1/2. So it just gets to hang out. And this, we know, is hyperbolic cosine. So the derivative of hyperbolic sine is hyperbolic cosine. That might go with your intuition. Now, what's your intuition for hyperbolic cosine? You might be thinking negative hyperbolic sine. So let's go ahead and actually take the derivative. So here, again, going to just use the identity, e to the x plus e to the negative x divided by 2. When we take the derivative, we get e to the x, and that becomes minus e to the negative x divided by 2, which is equal to positive hyperbolic sine. So notice there's no negatives attached to that. So both of those derivatives are going to be positive. So now that we have those identified, we're going to go ahead and use it for hyperbolic tangent. So here we're going to take the derivative, and we're going to end up using hyperbolic sine, which we already found the derivative for that, divided by hyperbolic cosine. We already found the derivative for that. And we are going to go ahead and use quotient rules. So we have the numerator and we have the denominator, and I'll go ahead and set it up. Okay, so we have these corresponding derivatives. We get cosh, as some people say, and sinh, as people say. It just sounds wrong, but I'll go with it. So here, when we use quotient rule, we start from the bottom, work to the top. So that becomes cosh squared of x, and we subtract. We start from the top, work our way to the bottom, and that becomes sinh squared of x, and then divided by the denominator squared, so that becomes cosh squared of x. And remember, this is an identity. We get 1 over because that whole numerator is equal to 1, and I'll scroll back up here, and it's because we're using this kind of parabola, which results in that kind of formula. So going back down, we get 1 over cosh squared of x, which is equal to the hyperbolic secant squared of x. I don't know what people would call that, but yeah. Now we're going to go ahead and do the same thing. We're going to set up quotient rule for hyperbolic cosecant, which is 1 over hyperbolic sine of x. So here the derivative of 1 is just going to be 0, so that's super nice. And the derivative of sinh is going to be cosh, and we're going to go ahead and use quotient rule. So here we start from the bottom, work our way to the top. That just becomes a 0. Subtract from the top to the bottom. That becomes 1 times cosh, which is just cosh. And then divided by the denominator squared, which is going to be sinh squared of x. So let's go ahead and split this up into two fractions. So in the numerator, we have negative cosh of x. And I'm going to take one of the pairs in the bottom. So I'm just going to take one of those sinh. And now we have that remaining 1 over hyperbolic sine of x. Here we can go ahead and write that as negative hyperbolic cotangent of x times hyperbolic cosecant of x. And here we have what that derivative is equal to. So that one's very similar to the normal trig. Actually, it's just with the hyperbolic functions now. So let's go ahead and see if hyperbolic secant is also similar. So again, we're going to go ahead and set it up using quotient rule. That's going to be rewritten as 1 over hyperbolic cosine of x. Okay, so that derivative is just going to be 0. Very nice. And then that's just going to be positive hyperbolic sine. So here with quotient rule, start from the bottom, work way to the top. That's just going to end up being 0 minus 1 times sinh is just going to be hyperbolic sine. Sorry, that's a weird sign. Divided by the denominator squared. So we get hyperbolic cosine squared of x. So again, I'm going to split it up just like I did the previous one. So we have that negative hyperbolic sine in the numerator divided by hyperbolic cosine, and then we have that remaining times 1 over hyperbolic cosine. So now we can split this up nicely. We get negative hyperbolic tangent of x multiplied by hyperbolic secant of x. So this one works out similarly. The only additional thing is that we have the negative. So when we work with normal trig, normally when we take the derivative of cosine, we get negative sign, which cancels out that negative. It's a minus and negative, so that becomes a positive. In this case, there's no negative to cancel out this minus sign, and so it remains a minus sign, which means this remains negative. We got one more here. Let's go ahead and work it out. We're going to do the exact same thing. So this becomes hyperbolic cosine in the numerator and hyperbolic sine in the numerator. Okay, so here we get positive hyperbolic sine of x, and then for g prime, we get positive hyperbolic cosine of x. So again, we see that negative is not going to cancel out, so let's see how we manipulate it. Work from the bottom to the top, that ends up being hyperbolic sine squared of x minus, and that becomes hyperbolic cosine squared of x divided by the denominator squared. So that becomes sine hyperbolic squared of x. So here, notice that the numerator is super close to the identity. We just need to have those terms switched. So what I'm just going to go ahead and do is pull out a negative 1. So that way I get hyperbolic squared of x, cosine, minus hyperbolic sine squared of x. And so when I pull out that negative 1, I end up getting that identity that I want, which is equal to 1, right? So this whole thing goes to 1. So in the numerator, we have negative 1 divided by hyperbolic sine squared of x. And so here that can be rewritten as negative hyperbolic cosecant squared of x. So that also is exactly the same as the trig, it's just a hyperbolic. So if you want to see it all in a nutshell, here we have all of the identities. So in one of my shorts, I showed that for normal trigonometry, the derivative of all the c's are negative. So with hyperbolic function, notice that that is not the same actually. We have the last three derivatives are all negative. So that's the 1 over sinh, 1 over cosh, and then 1 over tangent. So all of these that are like 1 over, those are the ones that are negative. It's no longer the c rule. But that's all I have for us in this video today. If you enjoyed it, I have many more like it, so make sure to check out my playlist. They're linked down below. Otherwise, please give this video a thumbs up and comment other problems or topics you'd like to see done. Thanks for watching.